Hello students, let's learn hyperbola today. Hyperbola is formed when you take the double right circular cone here and cut the two cones at an angle where it slices the cones, the upper nap and lower nap, just like so. And the resultant cross-section that you would get is a hyperbola. There are many real-life examples of hyperbola, just like the nuclear towers or the shade of light and shade patterns of a night light, and so on and so forth. So let's go more into the detail. Here you have the major axis. This is the major axis. This is a horizontal hyperbola. This is the vertical hyperbola. But the major axis is called the transverse axis. So the language is a little bit different. The words, the terminology, there are a couple of changes, not much. So the major axis is called a transverse axis, and the minor axis is the conjugate axis. So the only difference between, I wouldn't say the only, but the major difference between hyperbola and ellipse would be the minus sign in the equation, and of course the structure. The minus sign actually decides if it is horizontal or vertical in the case of hyperbola. If you have the minus sign on the y term and the x term here is positive, the x squared is positive, then the major axis would be horizontal, or the transverse axis is horizontal. If the y squared term is positive, then the conjugate axis would be vertical. Sorry, the transverse axis would be vertical. The other major thing you would see is the focus is, of course, inside the curve, but it's outside of the vertex this time. So the vertex is in between the focus and center, unlike in ellipse where the vertex is outside. The focus is in between the vertex and center. And hence, the figure is going to be curves pointing away from each other. And the other new thing that you would see here is the asymptotes. You will have asymptotes for hyperbola, where you see that the major axis or the transverse axis and the conjugate axis actually form a rectangle. You see that? The semi-transverse axis and semi-conjugate axis, if you actually extend them, they will form a rectangle, and the diagonals of them would form the asymptotes, and on which the hyperbola actually curves around. Okay, so the asymptotes also play a major role. All right, and the same here. It's just that it is vertical, so you will see it in this way. So looking at the details of the focus, the focal length, which is from the vertex to the focus, can be actually figured out using this formula, c squared equals a squared plus b squared. Yes, it looks like a Pythagorean theorem, and it's literally that so, because you will see that this is a and this is b, and hence you're finding the hypotenuse, the length of the hypotenuse, right? And that would be the C. It's somehow related to that. The derivation actually is not is beyond the scope of this course, but it's an interesting derivation, because the C is hypotenuse, but how is hypotenuse related to this? So all of this is figured out in another derivation, which is not part of this video. So here we have the transverse axis here is 2a, the semi-transverse axis is a, conjugate axis is 2b, semi-conjugate axis is b. Please take notes as I go ahead. And the asymptotes, this time the horizontal and the vertical. There are two kinds of asymptotes, right? For the horizontal hyperbola, this is how you will find y equals plus or minus b over a. Always the conjugate axis is on the top, depending on the situation, times x minus h plus k. Please do not put square here. This is a linear equation because the asymptotes are lines, they are not quadratics. So don't do the square here. Many students do, so don't do that mistake. And if it is a vertical hyperbola, this is the equation, y equals plus or minus a over b. Again, in this case, the conjugate axis is a, okay, times x minus h plus k. Okay, so these are the formulas. And now let's look at examples here. We are taking two examples, but they both mean the same, except for that we just have to decide which is horizontal and which is vertical. Okay, so here, as always, the opposite, you have to switch the signs because this is x minus of negative 2 and this is y minus y anyway. So the h is negative 2, y is 5. Whereas here, if you actually notice, the x is here, not on the first term. The first term is y. So please don't make a mistake. This is not h now. This is k still. Y minus k. Right? So k is 4 here, not h. And h here is negative 2. So just you have to be careful with those things. Okay? And here a, see, whatever is the major axis, that would be a. Right? Or not. This is like, yeah, whatever is at the bottom of here, the first term, right, in the case of hyperbola. So here a is 3 and b is 2, whereas here a is 4. This is a vertical this is a vertical hyperbola because y squared term is positive. So whichever is here, that's fine, but a doesn't have to be always greater than b. You have to keep that in mind. In these two examples, that's the case, but sometimes a will be smaller than b, then that's fine too. The point here is which one is positive. So you cannot compare completely between ellipse and hyperbola and say they're opposite to each other. No. So there are certain things that are different. Okay. Okay, center here is negative 2 and 5. Since x squared term is positive, the direction would be horizontal. And the vertices, now for that you have to now actually draw. So you have to first locate the center. Negative 2 and 5 is right here. And let's draw the axis lines. Not so perfect. And next you have to first figure out the a and b, the rectangle that is formed by a and b. Since it is horizontal, a is from here, the center is negative 2 and 5. Let me write that down quickly. And 3 units to the right, which is here. 3 units to the left, 1, 2, 3. And b would be 2 units up and 2 units down. Okay. Now you have to draw the rectangle. All of this would be in dashed lines. Only the main curve would be solid. So this is A and this is B, and the vertices would be negative 2 and 1, and on the left side would be negative 2 and negative 5. My bad, not negative 2. Actually, I'm wrong here too, isn't it? It's 2 and 5. Let me erase, my bad. It's 2 and 5. And here it would be negative 5 and 5. Okay? Negative 5 and 5 and 2 and 5. 1 and 5, my bad. I'm making so many mistakes. Really sorry. 1 and 5. And the co-vertices would be, now here the y value will change. So negative 2 and 7. And here it would be negative 2 and 3. right? Alright, now that we drew the rectangle, we can now go across and draw the diagonals which form the asymptotes. Right? And then we would actually draw the curve. Let me take a different color. Yeah, you have to go through the vertex also, right? So make sure you're doing that. Okay, not bad. Now we have to find the foci. To find the foci, you have c squared equals a squared plus b squared, and so c squared is 9 plus 4, so c is square root of 13, plus or minus, of course. So the foci will be horizontal also, right? So that would be negative 2 plus it's the x coordinate will change. So this is how it should be, comma 5. Okay, and then the equation of the asymptotes, y equals plus or minus 2 over 3 x plus 2 plus 5, because h and k. Okay, so this is it. So this is how you get the equation, the graph of. So if you look at here quickly, the center here is negative 2 and 4. The direction is going to be vertical, so you have to be really careful. So here negative 2 and 4 is somewhere here, again in the second quadrant, and you'll draw the axis lines. Oops. And on the axis lines, you have to pick A is 4 this time, meaning on here, like 4 above and 4 below. So this is negative 2 and 4, the center. So 4 above would be negative 2 and 8. And here 4 below would be at the axis line, negative 2 and 0. So let's write that down. And B is 3 units to the right, 3 units to the left, 1, 2, 3. I'll finish this and I'll get back to you. Okay, you can pause the video. Because of lack of time, I'm going to pause it, and I'm going to finish all this and get back to you. Okay, so this is the finished graph. This is going to be vertical, so don't make a mistake of drawing it horizontal after all of this. Even I tend to make that mistake. Okay, and then this is the C, the focus. This time it is a nice number without a radical. So you would add it on the y coordinate, because this time it's vertical. So negative 2, 9, and negative 2, negative 1. And these are the equations of the asymptotes. Okay, so this is how you decipher the hyperbola. In the next video, I'm going to show you how to convert the standard form of hyperbola into the vertex form. Okay, all right, thank you for watching. I'll see you next time.